Okay, so example 5, let's talk about finite and infinite sets. Okay, so from your handout, right, a finite set, right, so let's just say A. A is finite, right? You can say this, right, means if and only if the cardinality of A, right, is either 0, meaning there are no elements, right, or maybe let's kind of do this, or the cardinality of A is actually a natural number, right, meaning 5, 4, 7, 17 from our class. And let's just say A is, right, infinite, right, it's not finite. If the cardinality is not 0. So obviously it's just the opposite of the first one. So if I gave you, let's see. Okay, well, we talked about the empty set, right, which we denote as this guy. So, I don't know, or even if we want to call it that, if I ask you what the cardinality of the empty set is, you would say 0, because there are no elements in the empty set, right? There's none. And again, this is not a 0, right? That means empty set, okay? And this is the actual 0. Okay, what if, well, we talked about, we've talked about this before. I just haven't called it finite or infinite. So let's see. I think, so our class, okay, if I call it A, which is, again, is not the same A, if I refer to a different A. Our class, right, there was X1, X2, right, there's 17 students in our class. The cardinality of A, right, there's 17 members or 17 students. Now, 17 is obviously a natural number, right? 17 is in the set 1, 2, 3, 4, 5, and so forth. So since it's a natural number, right, then we know it's got to be finite, right? It's got to be finite. So from this, we know that A is finite, right? There's a finite number of objects in that set. If it's not finite, it obviously goes on forever, right? Infinite, infinity, that's where the word comes from. So if let's say my set is B, and let's say I'm saying it is X, such that X is a natural number. And let's see what I want to choose. And X is greater than, I don't know, 3. Okay, this is in set builder notation, right? So I want to know, is this set B? Is it a finite set? Can I actually count the number of elements in it? Or is it infinite? Does it keep going and going and going? Well, one of the ways is to rewrite this in roster form. So, whoops. Okay, so B in roster form. Again, some value X, right, such that, right, this is the general, right, this is, again, all real numbers, right, X is the fractions, the decimals, all the numbers that we work with in math. And there's 2 conditions. One of them is that X has to be a natural number. Okay, it has to be a natural number. Well, natural numbers are 1, 2, 3, 4, ... right? And the second condition is that natural number, right, the same one, has to be greater than or 3, not greater than or equal to 3. Well, 1, right, 1 is not greater than 3, right? 2 is obviously not greater than 3. 3 is not greater than 3 because 3 is equal to 3. So our set, right, if you want to write it a little bit nicer, our set is 4. All numbers greater than 3 are 4, 5, 6, 7, 8, right? I mean, there are a lot of numbers greater than 3. So this set, B, is an infinite set, right? Because it goes on to infinity. If I ask you how many numbers are greater than 3, I mean, you can't give me a fixed value. You know, there are a million numbers greater than 3. No, there's a lot more than a million. So that is example, I think it was 5. Okay, so make sure you understand these this set notation.